You're welcome to Medical Sciences Made Easy by Naphtali Muhumuza here in Uganda. We are always at your service. We have brought medical services closer to you. And today we want to introduce hematology. And this hematology is taught even it is part of physiology, whereby when we are talking about blood, but particularly here we want to introduce it under hematology as a course unit. So hematology is made up of two words, that is heme and logos. These are Greek words, or logi. And this heme means blood, and logos means study. So in summary, hematology is the study of blood, is the study of blood. So this is what we are going to discuss about. We want to know what is blood. After knowing that hematology is study of blood, or it is the branch of science that deals with the study of blood, in this hematology we are going to go further and we look at how blood is formed. We want to look at how blood is formed. After knowing how it is formed, we shall need to know how it is, what is in the blood, the composition. We shall look at the composition and functions of blood. And after knowing the composition, we shall still need to know the disorders. So this is what entails in blood. So hematology is going to be the branch of science that deals with the formation, composition, and function, then plus disorders of blood. So we look at how blood are formed by a process known as hematopoiesis. Then we see the composition and the function of blood, and we see also disorders of blood. That is hematology. Hematology is a branch of science that deals with the study of blood, that is formation, composition, and disorders of blood. And this blood we are talking about, blood is red in color. It is red in color, and we normally say it is a liquid connective tissue. It is a liquid connective tissue, red in color. The liquid connective tissue, red in color, it is composed of plasma and formed cells, whereby the plasma in the blood, it occupies 55%, whereas the formed cells occupy 45%. And we have said this blood is red color. For example, when blood is oxygenated, we shall find that oxygenated blood, for it is bright red. It is bright red due to the presence of oxygen, but this is arterial blood. Arterial blood. Arterial blood, because of presence of oxygen, it is bright red. Whereas venous blood, for it due to presence of much carbon dioxide and little oxygen, it is purple red. Purple red or dull red in color. So this is how you can distinguish between an arterial blood and a venous blood. Arterial blood, due to presence of much oxygen, it is bright red in color, and venous, because of little supply of oxygen, it is purple red in color. And this blood we are talking about today, in the human body, we find this blood, it weighs 7 to 8% of total body weight. Total body weight. And in terms of liters, it measures 5 to 6 liters in adult. This is the truth about blood, and its pH. Its pH is always between 7.35 to 7.45 with average of 7.4, and its specific gravity is 1.025 to 1.029. This is the specific gravity of blood, and this is the pH with average of 7.4. So we have seen it weighs 7 to 8 of total body weight, 5 to 6 liters, and this is its pH, and this is its specific gravity. After knowing this, now we want to see the composition of blood. After knowing what blood is, that it is liquid connective tissue which is red in color, and it is composed of plasma and cells. Then we have seen the color in both in the arterial and the venous, and the body weight, liters, pH, and specific gravity. So now we want to talk about the composition. What do we find in this blood? So the subheading is composition of blood. If I can draw this blood collected in the vagina, if I collect blood in the laboratory in the vagina or by the nurses, and this is whole blood. This whole blood, when I leave it to stand for long or when I centrifuge it, we shall find the cells settle at the bottom. The red cells settle faster at the bottom, whereby these ones will become red blood cells. Then on top of the red blood cells, we find a small layer, a white layer. And this white layer, which is small here on top of red cells, is known as the buffer coat. And this buffer coat contains platelets and white blood cells. Then the remaining portion is plasma, and this plasma is always pale yellow in color. It is always pale yellow in color, and so from here to here, it is plasma, which is pale yellow. Or you can say straw colored. Some books say straw colored. So this is what whole blood contains. So from here up to here, it is whole blood. But when we centrifuge it, or when we leave it to stand at room temperature for to stand for long or to centrifuge it, we are able to form red cells, the buffer coat, and the plasma. And we have said that this is red cells together with the buffer coat containing platelets and white cells is the one that composes formed cells. Formed cells, and these formed cells, we said they occupy 45%. Occupy 45%, whereas the plasma occupies 55%. So as we go on, we are going to look at what do we find in the plasma and what do we find in the cells. And we want to begin with the plasma. So you'll allow me the plasma components, I put them here, that if we have plasma in the body from blood, this plasma contains water We said this is 55%. It contains water, and this water, it occupies 91 to 92% of the plasma, whereas the remaining 8 to 9% is solids. Or we can call them solids or solutes. Solutes, they take 8 to 9% of plasma, whereby these solutes, we can see solutes like nutrients, we can see hormones and enzymes, we can see substances like electrolytes, see substances like waste products of metabolism, you see gases, whereby gases majorly we see oxygen and carbon dioxide as the major gases found in the body. Of course, plus nitrogen, when you can find there nitrogen. But majorly it is oxygen and carbon dioxide. Then under nutrients, we find in the nutrients, we have, these are macromolecules, whereby we have proteins, we have carbohydrates, we have lipids, we have vitamins. Vitamins or vitamins are also part of the body nutrients, even plus trace elements. Yeah, also we can find there trace elements. So that is the composition of the nutrients, whereby in the nutrients we have the proteins, the carbohydrates, the lipids, vitamins, and trace elements, and sometimes nucleic acids. And these are the macromolecules we find in the body. And these proteins, sometimes we can categorize them as albumin, whereby albumin covers 54%. Then we have globulins and fibrinogen. So those are the compositions. So we can even separate these proteins by electrophoresis method, whereby by electrophoresis we see these proteins being separated according to their density and mass, according to their mass and the charge, density and the charge. Then carbohydrates, they are also components are many. We can classify them as we go on. Then hormones and enzymes, there are very many. We can't list them here. So at least when you are in an exam, give some examples there. If you're on electrolytes, we know that electrolytes, they are composed of cations. We have cations and anions, whereby cations we have like calcium, sodium, magnesium. Then under anions we have like chloride ions, we have the bicarbonate ions. Then the waste product of metabolism, we are going to see waste product of metabolism, whereby there is urea, creatinine, ammonia. Ammonia is part, and uric acid. These are part of the waste product of metabolism. Creatinine, urea, ammonia, and uric acid. So we see them being excreted they are transported by blood and excreted through the kidneys or through the skin. So this is the composition of plasma, whereby plasma, we have seen, we have water and solutes, whereby water is the major component of the plasma. Then we have seen in the solutes, which makes 8 to 9% being nutrients, hormones are mainly like testosterone, which I like most, the estrogen, because we are in this world because of those hormones are transported in the blood. Then enzymes, they are there. Also some are transported in the blood. Then waste products of metabolism, I have seen them being transported, and gases. So this is the composition. And we said that this plasma is straw-colored or pale yellow. After knowing the composition of plasma, now what we need to know is the composition of cells. In formed cells, what is there? So we have formed blood cells, and we say that these blood cells occupy 45% of the whole blood. 45% of the whole blood. And these cells, we saw, the way we saw here that the first one segment is the RBCs, the red cells, or what you can call erythrocytes. You can call them erythrocytes. And these ones are the ones that segment first in cells. And we know that these cells, they are biconcave disc in shape, which measures between 6 to 8 micrometer in diameter. So you find that these red cells, they are biconcave disc in shape. If I draw them to show the biconcave disc in shape, this is how they look like, and they lack the mitochondria, and they measure between 6 to 8 micrometer in diameter. So at a resting state, red cells appear like this, with area of central pillar, which covers a third surrounded by the hemoglobinized area. And this is how red cells look like. Then, after knowing the red cells, in the buffer coat, we find platelets, and these platelets, you can call them thrombocytes. Thrombocytes. And these thrombocytes, they are discoid in shape. They are discoid in shape. These are discoid in shape. And they measure between 2 to 4 micrometer in diameter. In diameter, they measure 2 to 4 micrometer in diameter. And these, they are just cell fragments which are got from the blockage of the megakaryocyte. And their major role in the blood is that they are responsible. Their role in the blood is they are responsible for blood clotting. Blood clotting in case of injury. When there is an injured site, we see these platelets playing a big role in what we call primary hemostasis, whereby primary hemostasis is the formation of a platelet plug, which leads to stopping of the blood flow during injury. And that is their major role in the body, of blood clotting. Then, for here, the function of red cells for them, their major role is to transport gases. They transport carbon dioxide and oxygen. Oxygen from the lungs to the respiring cells or tissues. Then we see red cells transporting carbon dioxide from respiring tissues or cells to the lungs for expiration, to the lungs for exhalation. So the major role of red cells is to transport carbon dioxide and oxygen. And another thing, we see them acting as buffer because they contain hemoglobin. So they act as body buffers, whereby they maintain body pH. They act as buffer to maintain body pH due to presence of hemoglobin, which acts as the buffer. Then we look at leukocytes. Want to look at leukocytes, white blood cells known as leukocytes. And these leukocytes, They are divided into two, whereby they are divided into the granulocytes and agranulocytes. That is according to Romanowski stains, whereby the granulocytes include the neutrophils, include the eosinophils, and the basophils, the bends. So these ones, in summary, we call them bends. A bend. Then granulocytes meaning they have granules in their cytoplasm. When you stain them with Romanowski stains, you see granules, presence of granules in the cytoplasm. Whereas the granulocytes, for them, they lack granules in their cytoplasm. And they include mole. Mole whereby we have monocytes and lymphocytes. And these monocytes, we normally abbreviate this one we saw they are bends. These ones are ben. The granulocytes which have the granules in the cytoplasm, we called them ben. This one we have called them mole. So this is, you can use it to always remember them. Then these monocytes, we shall continue to see that these lymphocytes, they divide into large and small, whereby the small are called the B lymphocytes, then the large are called the T lymphocytes. And we shall see that these T lymphocytes can divide into T cytotoxic, T helper, and T regulator. Then the B lymphocytes, for them, they proliferate into plasma cells, and these plasma cells are the ones that produce antibodies that render our body immunity, whereby these participate in what we call cellular-mediated immunity, and this one is humoral-mediated immunity. So we see lymphocytes playing a big role in providing immunity into our body, that when there is a pathogen that enters, we see these guys coming into play. Then the monocytes, for them, their major role is that they act as scavengers, whereby they are phagocytic cells. They do phagocytosis. Majorly it is phagocytosis. And these ones are also phagocytic cells, whereby they participate like neutrophils and eosinophils. They are phagocytic cells, whereas basophils, we shall also see their importance. And to always remember their percentage in saturation, we always remember a mnemonic whereby we say, never let monkeys eat bananas. Never let monkeys eat bananas. Whereby never stands for neutrophils, let stands for lymphocytes. Monkeys is monocytes, then this is eosinophils, then this is basophils. That is in adults. This is in adults, whereby neutrophils account for 50 to 75%. Lymphocyte is 20 to 40% in adults. Monocyte is 2 to 10 in adults. Eosinophil is 1 to 6%. Then basophils is less than 1%. This is their composition in the blood circulation. So never let monkeys eat banana can always remind us on the composition of blood cells, that is the white blood cells in circulation. That is in adults. But in children, we see neutrophils, the lymphocytes become higher than neutrophils. That is in children. That is in children. So we have seen the composition. This is the composition, whereby you have seen plasma and cells, And we have seen the composition of plasma, and we have also seen the composition of cells. Lastly, in introduction, we want to talk about functions of blood in the body. Because we want to ask ourselves, why blood? Why do we study blood? We want to look at the functions. And allow me to put them here. Functions of blood. In the body. And these functions of blood in the body, they are majorly categorized into three, whereby one is transport, the second one is regulation, and the third one is defense or protection, or you can call it protection. And I can even add the fourth one, and the fourth one is storage. You can also see them playing a big role in storage. So these are the four major ways we can categorize these, but in an exam you don't need to categorize. And under transport, we see blood transporting respiratory gases, like carbon dioxide and oxygen. Carbon dioxide from respiring cells to the lungs for expiration, then oxygen from the lungs to the respiring cells to provide energy for cellular respiration. Then we see also transport of nutrients like proteins, carbohydrates, that is glucose, then lipids, vitamins, or being transported by blood. We see another role under transport is transportation of waste products of metabolism. Waste of products like urea, ammonia, creatinine. They are also transported by blood. And we see also transportation of hormones. Hormones are also transported in blood. That is the function of transport. So these are 4 points. This is point number 1, transport of respiratory gases, transport of nutrients, transport of waste products of metabolism, and you give an example, transport of hormones, and you give an example. I told you I like testosterone, estrogen, and more others. So you give at least 2 examples whenever, because the question comes saying outline like 10 functions of blood. After looking at the function of transport, then the second one is regulation. How does blood regulate or keep our internal environment at a constant? So under regulation, we see blood playing a key role in maintaining acid-base balance, doing a role of acid-base balance, that is maintaining the blood pH. And we saw the action of blood like the red cells which contain hemoglobin, which was acting as the buffer. Then we see this blood also doing the regulation of osmotic pressure. Osmotic pressure or oncotic pressure. And this role is majorly played by albumin, whereby when we have albumin in blood, albumin tends to create the oncotic pressure, osmotic pressure, the pressure that forces fluid to keep. We know that when we have blood vessels, this is my blood vessel, there is a force that forces fluid to go out of the cell. That is hydrostatic pressure, and there is the pressure that also tends to keep the fluid inside. And this force is what we call osmotic pressure. Osmotic pressure is the one that tends the fluid to remain. So it is created by albumin, and that is which is part of blood. And finally, this we see this blood also regulating temperature. It regulates temperature, body temperature, whereby blood supplies heat to all tissues. That's why when we need more oxygen, blood, that like we need more heat, we see blood being supplied near the, and so it maintains the body temperature. When there is coldness, the vessels vasoconstrict to reduce the blood supply near the skin. And when there is heat, we see the vessels vasodilating, allowing blood to come near the surface to lose heat. So it maintains body temperature. Then under defense, we have seen cells like monocytes, cells like neutrophils, which do the role of phagocytosis. So they defend the body by engulfing any pathogen or foreign material that enters that can cause a disease. And that is what we call phagocytosis, played majorly by the monocytes, and in the tissues we call it macrophages. Then even the neutrophils doing that alone. Then we have seen also another defense mechanism is by the T lymphocyte, by the lymphocytes. And we said these lymphocytes are divided into T and the B lymphocyte, and the B lymphocytes produce antibodies that render body immunity, provide immunity to the body by the production of antibodies known as immunoglobulins. Then these ones, the T cytotoxic, for them they kill. T cytotoxic, T helper, which play a big role in cellular immunity. This is cellular immunity, this is humoral immunity. So that is then fine. We also saw platelets. Platelets playing a role in blood clotting, what we call hemostasis, which is also part of body defense. So under defense, we have 3 points, whereby monocytes and neutrophils plus little of eosinophils doing the role of phagocytosis, then lymphocytes providing immunity, and platelets providing humoral. Then lastly, there is the storage of glycogen, like glycogen, whereby there is storage, like glucose, we store it in the form of glycogen. Thank you so much for listening. Meet next time.